Okay, my dear students, today let us discuss about direction cosines and direction ratios. Before that, as I told earlier, if r bar is equal to xi plus yj plus zk, then its magnitude modulus of r bar is equal to x square plus y square plus z square. In the same fashion, if I take this one as if P of or else OP bar is equal to, OP bar is equal to, that is x1i plus x2j or else y1j, z1k. OQ bar is equal to x2i plus y2j plus z2k. Then PQ bar can be expressed as position vectors of its extremities. So therefore, OQ minus OP, the position vectors of its the terminal point minus initial point. That gives, now I can write this one as x2i plus y2j plus z2k minus, that is x1i plus y1j z1k, right? So now you group the terms having the same component, that is x2 minus x1 into I, next y2 minus y1 into j. Now this becomes z2 minus z1 into k. So therefore this is nothing but a PQ bar. When this is PQ bar, then what is modulus of PQ bar? Modulus of PQ bar can be written as, yes, x2 minus x1 whole square plus y2 minus y1 whole square. This is z2 minus z1 whole square. Yes, when you are given with what? The position vectors of 2 points, I can write that vector as what? Position vectors of its extremities. In that case, how to find out the what? The magnitude or length of that vector, we came to know that. So therefore, modulus of PQ bar is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So therefore, I can also write this PQ bar as, I can also write x2 minus x1 y2 minus y1 z2 minus z1. Later we are expressing these as components, means scalars are nothing but a components. So therefore it's a scalar or a component along x-axis, it's a scalar or a component along y-axis. In the same fashion, z2 minus z1 is a component along z-axis. So therefore next we shall understand what is the direction cosines and direction ratios. Direction cosines and direction ratios. Now, DCS of a line. DCS of a line. Now, if I getting into the what? X-axis, y-axis, z-axis. So therefore, if I go to this one as, this is OP is equal to A bar. This A bar is nothing but, A bar is equal to A1I plus A2J A3K. OP bar is equal to A bar is a ray or a line. That line is treated with a vector notation. That too, that line OP bar is given by A bar. In turn, A bar is A1I plus A2J plus A3K. So therefore, now always this is with what? I. This is what? J. This is what? K. Now scalar or a component along x-axis what? A1. Component along y-axis A2. Component along what? A3. let alpha, comma, beta and gamma be the angles made by the line or a ray OP bar represented with the vector A bar. I mean, let alpha, comma, beta and gamma be the angles made by the vector A bar with the positive direction of x, y and z axis respectively. So therefore, if I take this as alpha, if I take this as beta, so actually up to here, it is actually, you can combine with this one is, this is also what gamma, right? Under gamma, alpha is also included. So therefore, when alpha, comma, beta, comma, and gamma be the angles made by the vector A bar with the positive direction of x, y and z axis. So therefore, now I can write, then let alpha, comma, beta and gamma be the angles made by the vector A bar or a line or a ray with the positive direction of x, comma, y and z axis respectively. Then if I measure these angles in terms of cosine of the function, I mean cos alpha, cos beta and cos gamma are known as DCS of a line. DCS of a line are known as DCS of a line. Right. Now once again, let A bar is equal to A1i plus A2j plus A3k be the vector or a ray or a line which makes an angle alpha, beta and gamma with the what? Positive direction of x, y and z axis. Then cos alpha, cos beta, cos gamma are known as DCS of a line, direction cosines. Let us see, if I construct a triangle here, it is very easy to comfortable to what triangle. You can apply cosine of the angle, adjacent side by hypotenuse. So therefore, one triangle I can show comfortably. You have to understand in a similar fashion. So therefore, now from figure, I can write cos alpha is equal to A1 by modulus of A. You can construct a triangle here. That goes without saying, no need to construct. You have to understand the perception is left to the student how to construct a triangle. And it is a 3D plane. So it will be not comfortable, go for what? Z axis. So go with what? X axis. And this is applicable, generalized for y and z axis respectively. So therefore, cos alpha is equal to A1 by modulus of A bar. A1 is the component along x axis. A2 is the component along y axis. A3 is the component of A bar along x, y and z axis respectively. So therefore, A1 by modulus of A bar. Similarly, I can also write cos beta is equal to A2 by modulus of A bar. Cos gamma cos gamma is equal to A3 by modulus of A bar. So therefore, these are the what? DCS of a line. I can write for all the three, I can write DCS of A bar is nothing but cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma. I can write instead of cos alpha, cos beta, cos gamma, I can also write A1 by modulus of A, A2 by modulus of A, A3 by modulus of A. Here, cos alpha, cos beta, cos gamma. Followed? Right. So when DCS of A bar is this. Now, look here. When DCS of A bar is A1 by modulus of A, A2 by modulus of A, A3 by, this also call it as, look here, I can also call it as, this is L, this also what, M, this is what, N. Element are also what? DCS of a line. Alpha, beta, gamma are the angles measured in the positive direction. What is the other direction? 180 minus alpha. Right? If two lines are intersecting, one angle is theta, other angle is 180 minus theta. That is quite obvious. In the positive direction, alpha, beta, gamma, cos alpha, cos beta, cos gamma. In the negative direction, cos of 180 minus alpha, cos of 180 minus beta, cos of 180 minus gamma. Therefore, cos of 180 minus alpha, minus cos beta, minus cos gamma. When we have taken cos alpha as a L, cos beta as a M, cos gamma as a N, then in the negative direction, what are the DCS? Minus L, minus M, minus N. So therefore, the DCS of any line is plus or minus L, plus or minus M, plus or minus N. But I am talking about in the positive direction. So therefore, DCS of A bar is equal to A1 by modulus of A bar, A2 by modulus of A bar. Yes, when you know the DCS of A bar, say for example, if I take R bar is equal to Si plus 2, that is 1 plus 4, that is 116. So therefore, this is what? 3K. Right. I plus 2J plus 3K. So DCS of, DCS of R bar is, now you can find out modulus of R bar. Yes, now this is nothing but square root of 1 plus 4 plus 9 is equal to what? Root 14. So therefore, DCS of A bar is 1 by root 14, that is 2 by root 14, next 3 by root 14, right? This is DCS. Okay. Now, alpha is the angle made by the what? A bar with x-axis. You know the DCS of A bar. I can also write, now when you know the DCS of a line, then I want to find out angle made by the line or a ray or a vector A bar with x-axis is alpha is equal to cos inverse of A1 by modulus of A bar. Come on, with y-axis is beta is equal to cos inverse of A2 by modulus of A. With z-axis, gamma is equal to cos inverse of A2 by A3 by modulus of A bar. So therefore, remember, when you came to know that what, DCS of a line or a ray or a vector as A1 by modulus of A, A2 by modulus of A, A3 by modulus of A. There is another application that goes without saying. What is that? The angle made by the vector with the positive direction of x, y and z axis. Yes, Cos alpha is equal to A1 by modulus of A. Therefore, alpha is equal to cos inverse of A1 by modulus of A bar. Similarly, beta is equal to cos inverse of what? A2 by modulus of A bar. And gamma is equal to what? Cos inverse of A3 by what? Modulus of A1. Yes, from this one, I can write this one as, what is, come on, look here. What is modulus of A bar? Modulus of A bar is equal to A1 square, A2 square, plus A3 square. A1 square plus A2 square plus A3 square. Now, from this concept, I want to give another one like application. Cos square alpha, cos square beta, cos square gamma. Yes, what is cos square alpha? A1 square by modulus of A bar whole square. A2 square by modulus of A bar whole square. A3 square by modulus of A bar whole square. Now, we know that A1 square, A2 square, A3 square by modulus of A bar whole square. As I told earlier, this is nothing but modulus of A bar whole square. Cancel it. This becomes 1. Yes, we have arrived at a result. Cos square alpha plus cos square beta, cos square gamma is equal to 1. Yes, the sum of the squares of the direction cosines is equal to 1. Yes, now coming this one is, after knowing this, I can also write 1 minus sine square alpha, 1 minus sine square beta, 1 minus sine square gamma is equal to 1. So therefore, which implies sine square alpha, sine square beta, sine square gamma is equal to 2. Yes, this is the application of 1 only. No, this is one way. Sigma sine square alpha is equal to what? 2. Yes, in the same fashion, I can also write when cos square alpha plus cos square beta. Cos square alpha, cos square beta, cos square gamma is equal to 1. Now I can write, yes, cos square. What is 1 plus 2 cos 1 plus cos 2 alpha? We know that 1 plus cos 2 alpha is equal to 2 cos square alpha. 2 cos square alpha, right? So therefore, now I can write this is 1 plus cos 2 alpha by 2, 1 plus cos 2 beta by 2, 1 plus cos 2 gamma by 2 is equal to 1, right? You cross multiply 2, this becomes 1 plus cos 2 alpha, 1 plus cos 2 beta, 1 plus cos 2 gamma is equal to 2. Now add up 3 ones, 1, 1, 1, 3 plus cos 2 alpha, that is cos 2 beta, cos 2 gamma is equal to 2. So therefore, sigma cos 2 alpha, cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to minus 1. Transfer 3 to this one is, this becomes 2 minus 3 is equal to how much? Minus 1. Yes, we can also write in terms of what? Sine also. Yes, we come across up to now, what is that is? Direction questions as, let alpha comma beta comma gamma be the angles made by the vector A bar is equal to A1i plus A2j plus A3k with the positive direction of x, y and z axis respectively. Then cos alpha comma cos beta comma cos gamma are known as direction cosines. Later we found out cos alpha is equal to A1 by modulus of A bar. Cos beta is equal to A2 by modulus of A bar. cos gamma is equal to A3 by modulus of A bar. Later, I told the angle made by the vector with the positive direction of x, y and z axis. Alpha is equal to cos inverse of A1 by modulus of A bar. Beta is equal to cos inverse of A2 by modulus of A bar. Gamma is equal to cos inverse of A3 by modulus of A bar. Then we went to discuss what is that? The sum of the squares of the what direction cosines is equal to 1. I mean L square. This is also nothing but I can also write L square. This is M square. N square is equal to 1. L square plus M square plus N square is equal to 1. And next we went for sin square alpha plus sin square beta plus sin square gamma is equal to. Later with what? 1 plus cos 2 alpha, multiples and submultiples. 1 plus cos square alpha is nothing but 1 plus cos 2 alpha by 2. 1 plus cos 2 beta by 2. 1 plus cos 2 gamma by what? 2 is equal to 1. Then, so simplify. I got it, cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 2. Transfer 3 to that side. It becomes sigma cos 2 alpha is equal to 2 minus 3. It becomes minus 1. Hereafter, whenever and wherever we come across LMN or the DCS of a line, or LMN or nothing but cos alpha, cos beta, cos gamma or the DCS of a line, yes, sigma cos alpha, cos square alpha is equal to 1. Sigma sin square alpha is equal to 2. Sigma cos 2 alpha is equal to what? Minus 1. Followed. Next. Now the application of direction cosines. Now, note, if L, M, if L, M be the DCS of a line, then maximum value of LM. Yes, maximum value of LM. Now, which has only two direction cosines, L and M. Certainly it must be a 2D line. I go for this one is when L, M, it's a 2D vector that is defined in xy plane. L, M or the DCS of a line or vector, we know that L square M square is equal to 1. Sum of the squares of the direction cosines is equal to 1. Yes, and also this is a product. Means product means a function which contains how many variables? 2 variables. If that is to be maximum, both must be equal. Then only maximum comes. So therefore, if L is equal to M, then it becomes maximum. Then 1 implies 2L square is equal to 1, which implies L is equal to plus or minus 1 by 2. Since we are measuring in the positive direction, I am taking only 1 by root 2. Instead, minus 1 by root 2. When L is equal to 1 by root 2, we had this 1 by root 2 when L is equal to M. It is quite obvious. I can also write M is also what? 1 by root 2. Therefore, now maximum value of LM is 1 by root 2 into 1 by root 2 is equal to 1 by 2. So therefore hereafter, so whenever if L, M be the what? DCS of a line, then the maximum value of this LM. Yes, now when L, M are the DCS of a line means only, so therefore 2 L, M. So therefore it must be a 2D line or 2D vector. I mean it's defined in x and y axis, I mean xy plane. So therefore L square plus M square is equal to 1. Now if this product is to be what? Maximum, L must be equal to what? M. So therefore, 1 implies 2L square is equal to 1. L is equal to 1 by 2. M is equal also what? 1 by n by 2. So therefore, maximum value of Lm is what? 1 by root 2 into what? 1 by root 2 is equal to what? 1 by 2. Yes. So now coming this one is, if L comma M comma N are the DCS of a line, DCS of a line, then the maximum value of Lmn is dash. Maximum value of Lmn is dash. So therefore, now let us start. Proof of this one is, let L comma M comma N, let L comma M comma N be the DCS of a line or vector or a ray. Then we know it already from the what discussions. Sum of the squares of the what? Direction cosines is equal to 1. That is, L square plus M square plus N square is equal to what? 1. L square plus M square plus N square is equal to 1. So therefore, now you got it. You call this 1. We know it already. Now, for maximum value of Lmn, L must be equal to M must be equal to N, because which comprises 3 variables. For example, if you take a volume of a water tank is maximum. How do you say? So volume of a water tank is maximum. The water contained in water tank is maximum. We say tank is very full. Means there 3 parameters are there: length, breadth and width. If the amount of water contained in that water tank is to be maximum, provided length must be equal to breadth must be equal to width. Then only we say maximum. The area of what? Area of the triangle formed by the what? Is maximum. Which triangle? Isosceles, equilateral triangle, scalene or something, right angle triangle. We go for what? Equilateral triangle. Why? Length of all the sides are equal. If we go to the what? Maximum area of a quadrilateral. If that quadrilateral is a square, what come on? Rectangle, parallelogram, something. We go for square. While in a square, length of all the sides are equal. If this is to be what? Maximum. If this function is to be maximum, which comprises 3 variables, L must be equal to M is equal to what? N. So therefore, 1 implies what? 1 implies 3L square is equal to 1. Therefore, L is equal to 1 by 3. When L is equal to 1 by 3, since which implies M and N are also equal to 1 by 3. Minus 1 by root 3 is also there, but we are not considering the negative direction. We are taking strictly the discussion on the positive direction. Therefore, I have taken L is equal to 1 by root 3. M and N are also 1 by root 3. With these values, take and substitute in this product. So therefore, the maximum value of Lmn is 1 by root 3, 1 by root 3, 1 by root 3. This is what? 1 by 3 root 3. Now, student friends, you say we have come across if L, M, N are the DCS of a line, then the maximum of Lmn, maximum value of Lmn is what? 1 by 3 root 3. Just you take the what? L, M, N be the DCS of a line or a vector or array. Then L square plus M square plus N square is equal to 1. Call it as 1. Now, for maximum value of Lmn, M must be equal to what? N. So now you substitute these values in 1. 3L square is equal to 1. L is equal to 1 by root 3. Similarly, M is equal to N is equal to 1 by root 3. Therefore, the maximum value of Lmn is equal to what? 1 by 3 root 3. Right. So now, we shall have a what? The application of direction cosines for the third one. Note 3. What is note 3? Listen here. Note 3. If L, M, N are the DCS of a line, then the maximum value of Lm, Mn, Nl is dash. Yes, now it's a product. Two direction cosines. Now what I do is, the proof of this one is, let L, M, N be the DCS of a line. DCS of a line or a vector or array. And we know that AM, arithmetic mean, is always greater than or equal to geometric mean, is always greater than or equal to what? A harmonic mean. AM is greater than or equal to GM, is always greater than or equal to HM. At this context, I do not want HM. I am very much sufficient with what? AM and GM. So therefore, by using AM is greater than or equal to GM, so therefore, L square, M square by 2, AM of this one is. Students, you know already, when A, B, C belongs to AP, which implies 2B is equal to A plus C, or AM of A, B is equal to A plus B by 2. GM of A, B is what? Square root of AB. With this what? Come on, AM and GM, I am writing now instead of L, M, N, I am going to consider L square, M square. They are also DCS, direction cosines. So therefore, L square plus M square by 2 is greater than or equal to square root of. If you have two terms by 2, here also square root. Now this is L square, M square, which implies L square plus M square is greater than or equal to 2LM. Next, M square plus N square by 2 is greater than or equal to M square, N square, M square plus N square is greater than or equal to 2Mn. If they come out from the square root, it becomes Mn. Now N square plus L square by 2 is nothing but N square greater than or equal to what? L square. Now this is N square plus L square 2 into NL. Add up. Yes. As you know already, L square plus M square 2LM. M square plus N square 2Mn. N square plus L square is 2NL. Add this. This becomes 2 into L square plus M square N square is greater than or equal to 2 into LM, Mn, NL. 2 into LM plus Mn plus NL. Now, this 2 and 2 goes, and also we know that when LMN or the what? DCS of a line, we have proved cos square alpha plus cos square beta plus cos square gamma is equal to 1. Nevertheless, L square plus M square plus N square is equal to 1. L square plus M square plus N square is equal to 1. So therefore, I can write this 2 goes, this is 1 is greater than or equal to LM, this is MN plus NL. After removing the 2 on both sides, this value becomes what? N. Now I can write this one as ILM plus MN plus NL is less than or equal to 1. So therefore, less than indicates what? Maximum. Greater than indicates what? Minimum. So therefore, so now I can write hereafter the maximum value. Hello? Maximum value of LM plus MN plus NL is what? 1. Yes? Students, we come across today the applications of direction cosines as what? Under the 3 contexts, that means applications. When L, M are the what? DCS of a 2D line, then the maximum value of LM is what? 1 by 2. If L, M, N are the DCS of a line, then maximum value of LMN is what? 1 by 3 root 3. So if L, M, N are the what? DCS of a line, then the maximum value of LM plus MN plus NL. Yes, when LMN are the DCS of a line, we know that L square plus M square plus N square is equal to 1. When LMN are the DCS of a line, similarly L square, M square, N square also DCS of a line. For that L square, M square plus N square, I made use of what? AM and GM property. Yes, we know that already. AM is greater than or equal to GM is greater than or equal to HM. So I don't want at present HM. I went with the what? AM is greater than or equal to GM. So therefore, when AM is greater than or equal to GM, L square plus M square by 2 is greater than or equal to square root of by 2 square root. 3 terms, cube root. 4 terms, fourth root. Sum of n terms, nth root. You know already very well, AM and GM. 2 means, 3 means, n means. Okay, L square plus M square by 2 is greater than or equal to square root of L square M square. In the same fashion, M square plus N square by 2 is greater than or equal to square root of M square N square. N square plus L square by 2 is greater than or equal to square root of N square L square. Followed? So therefore, now I made use of that one, cross multiply, I got it 2LM, square root of L square M square is LM, next MN, next NL, cross multiply 2 from the denominator. So add up, I added all these inequalities. Now A 2 into L square plus M square plus N square is greater than or equal to 2 into LM plus MN plus NL, 2 goes, and we know that L square plus M square plus N square is equal to what? 1. Yes, this is 1. So therefore, I can write in a reverse way, LM plus MN plus NL is less than or equal to 1. So therefore, the maximum value of LM plus MN plus NL is what? 1. Yes, today we understood the definition of what? Direction cosines of a line. So, you have given a heading DCS and DRS. Yes. I come to the what? The difference between DCS and DRS. Every DCS or what? DRS. We come across in detail in the what? 3-dimensional geometry. Yes, now coming to DRS. Now DCS. Now DRS of a line. When element or the DCS, what's the DCS I told? Let alpha, beta, gamma be the angles made by the vector A bar or a what line or a what ray with the positive direction of x, y and z axis respectively. Then cos alpha, cos beta, cos gamma are known as DCS of a line. Then cos alpha, cos beta, cos gamma are also known as element, denoted with element. We come across it in detail discussion on those properties. When you know the what DCS of a line, what is DRS of a line? Three real numbers. Three real numbers A, B, C are said to be DRS of a line. DRS of a line or a vector A bar if A is to B is to C is equal to M, L is to M is to N. What does it mean? It means you take any three real numbers. If any three real numbers are to be defined as a DCS or DRS of a line, any three real numbers are said to be DRS of a line provided they must be proportionality with what? Direction cosines. What are LMN? DCS of a line. So therefore, these are the three real numbers. If they are proportionality with what? LMN, then they are what? Direction ratios. Any three real numbers, if they are proportionality with what? LMN, then we call it as what? Direction ratios. Yes, students, we understood the difference between the what? Direction cosines and direction ratios. Direction means what? Any three real numbers are said to be DRS of a line if they are proportionality with what? Direction cosines. Therefore, every direction cosines are what? Direction ratios. But converse is not true. So therefore, even every DCS are direction ratios. Yes, if LMN are, look here, if L, M, N are the DCS, note, I am going to write. If L, M, N are the DCS of a line or a vector, then LMN is the unit vector parallel to it. Note 2. If A, B, C are the DRS of a line or a vector, then A, B, C is a vector parallel to it. Because if you take its magnitude is equal to what? 1. How come, sir? L square plus M square plus N square is equal to 1. But square root of A square plus B square plus C square is not equal to 1. Hence, because of that reason, we could say it's a unit vector. It's a what? Vector. Yes. Today we understood the definition of what? Direction ratios and direction cosines. Right. After the direction cosines and direction ratios, let us discuss about definition of linear combination of vectors. Linear combination of vectors. What is linear combination of vectors? Linear combination of vectors. Yes, let A1 bar, A2 bar, A3 bar and so on, An bar be the system of vectors, then there are n vectors, there exists scalars. How many scalars? N scalars. Corresponding to n vectors, we have to go for what? N scalars. There exists scalars x1, x2 and so on, xn. Such that x1 into a1 bar, x2 into a2, that is x2 into a2 bar, x3 into what? Come on, a3 bar, and so on, xn into an bar. This is called linear combination of vectors. Linear combination of vectors. The linear combination of vectors means, look here, linear combination of vectors means the sum of the scalar multiplication of vectors is known as linear combination of vectors. The sum of the scalar multiplication of a vectors is what? Linear combination. So therefore, this is called linear combination of vectors. Under this, we come across two applications after knowing the linear combination of vectors. One is linearly dependent and linearly independent. Let us see what it is. Yes, linearly dependent vectors. This definition plays a vital role in addition of vectors, and this is the key factor for the what? Development of the applications in what? Vector algebra. You get very good questions in the objective level on this definition only. One must be very good in what? Application of this. Linearly dependent vectors. Other one is linearly independent vectors. Now, for linearly dependent vectors, let a1 bar, a2 bar, a3 bar, and so on, an bar, be the system of vectors. With the system of vectors. System of vectors are said to be linearly dependent. Are said to be linearly dependent, then there exists scalars x1, x2 and so on, xn, not all equal to 0. Not all equal to 0. Sir, what does it mean? Not all equal to 0 means at least one scalar must be different from 0. So, not all equal to 0. At least one scalar must be different from 0. So therefore, corresponding to n vectors, we have a n scalars, not all equal to 0, not all equal to 0, not all equal to, not all equal to 0, means at least one scalar is different from 0. At least one scalar must be different from 0. What does it mean? At least minimum one. Maximum all scalars must be different from 0. Minimum 1 may be different from 0, 2 may be different from 0, 3 may be, all may be different from 0. It means that for vectors a1 bar, a2 bar, a3 bar and so on, an bar to be linearly dependent, we are not imposing the condition on the vectors. We are imposing the values of the scalars, one must understand. So therefore, for that reason I am imposing the condition not on the vectors, but on the what? Scalars. So therefore, for that reason only, then there exist scalars, x1 to what, x2 and so on, xn, not all equal to 0. Means at least one scalar must be different from 0. So therefore, such that the linear combination of vectors is equal to 0. Linear combination is equal to 0, which implies x1 may be not equal to 0, x2 to all or may be equal to 0, or which implies, or this may be x1 to x2 may be equal to 0, x3 to what, x4 all may be different from 0, or I can also write x1 is equal to x2 and x4 not equal to what, 0, any one of the condition. It means that you might have understood, to prove the vectors as a what? Linearly dependent, we are not imposing the condition on the vectors. We are imposing the condition on the what? Scalars. Imposing the condition on scalars. So therefore, now x1 may be different from 0. x2 to what? xn may be equal to 0. Or x1, x2 may be equal to 0. All must be different from 0. All may be different from 0. Any one of the case may arise. Yes. Students, I am talking about n vectors. I am talking about n vectors. For your syllabus, you have the 3 vectors. When 3 vectors are given, corresponding to it, 3 scalars. Among the 3 scalars, at least one scalar must be different from 0. All may be different from 0. Followed? This is one way. The other method is that it is not a conceptual. Or instead of this, you won't get much concept on this. Or det must be equal to what? 0. Later stage we shall prove how it is. Or determinant is equal to what? 0. Means the det of all these vectors is equal to 0. This is a determinant. It may be 3 cross 3. It may be. Depends upon the vectors. But for your syllabus, 3 cross 3. It's a 3 vectors they'll give. Prove that 3 vectors as a linearly dependent. Remember, this definition is applicable only for vectors, not the points. Okay, so therefore, it's a linearly dependent vectors. Yes, now let a1 bar, a2 bar, a3 bar and so on, an bar be the system of vectors are said to be linear dependent, then there exists a scalars, n vectors corresponding to it. Not all equal to 0 means at least one scalar must be different from 0 such that linear combination is equal to 0. So therefore, what we told, not all equal to 0, x1 may be different from 0, all may be equal to 0, or any one of the cases may arise. This is what? Conceptual method. Thus, the problematic is what? This is det is equal to what? 0.